Electrical systems have a way of transforming between voltages and currents, similar to how a mechanical system transforms between forces and displacements using things like gears or rack and pinions or levers. In the case of an electrical system, this is done with a transformer. And a transformer consists of a ferromagnetic material, such as shown here, called a core, and two sets of windings where a wire is wound in a coil around two different sides of the system. One side is called the primary or input winding, and the other is the secondary or output winding. We've defined a voltage drop across the primary winding as well as a current going in, and a voltage drop across the secondary winding and a current coming out. The transformer properties are determined solely by the number of output turns divided by the number of input turns, often referred to by the number N. This is the ratio of secondary to primary windings. The polarity of the transformer is also shown, usually designated by these little dots here that show where the plus sign goes. The way a transformer works is that a sinusoidal current is applied across the primary winding, and that produces a sinusoidally varying magnetic field. That means that an AC voltage has to be applied, and the magnetic field is actually going to also vary sinusoidally, and that's measured with a quantity called the flux, designated by the variable capital phi. What the sinusoidal current does is it induces a flux that's actually shared throughout the core. So that means that the secondary winding also feels the same magnetic field as the primary winding. And in this case, the effect is that the flux produces a sinusoidal voltage across the secondary windings. Here we've redrawn the transformer, and we're going to provide the equations for transformation. And the first one is that you have two sinusoidally varying voltages with amplitudes that we're going to call V1 and V2. The ratio between V2 and V1 is given by N, which you recall is the ratio of the secondary windings to the number of primary windings. The effect on current is actually the opposite. So looking at the current coming out and the current going in, the ratio between the current going out and the current going in is actually 1 over N. If you multiply V1 times I1, you'll find that it's actually necessary for one of these ratios to be N and the other to be 1 over N, because you require the input power to equal the output power. So this makes it possible for V1 I1 to be equal to V2 I2. So what is there to remember about a transformer? First of all, the quantity N refers to the secondary windings divided by the primary windings. The ratio between the amplitudes of the voltages is V2 over V1 is equal to N, and then there's an opposite effect for the currents. Unfortunately, it's just necessary to remember these relationships, but this is all that's needed in order to be able to derive equations of motion for electrical systems with transformers.